Yep. All right. This will take a while. So we have to, today's September 26th. So it's always good in your notes to have, some separation. So when you're back looking for something, it's easy to find. And we are indeed going to be dividing polynomials. It's kind of nice that we get to do this. And then, like I said, we can put a bow on it and say, we've done it all. We can add, we can subtract, we can multiply, we can divide. So before we divide polynomials, I am going to do a review of something that you learned in 4th grade. And it's not to talk down to you. It's because the algorithm that we use, how many times does this go into this? You multiply, you put it here, you drop something, you subtract. I mean, there's a process to that we're going to be using today. So let's practice. No calculate. Calculators aren't going to help us for this week, just for the record. Unless you need it for like, how many times does 2 go into 8? Which you shouldn't. So let's say we did like 34,761, and we were going to divide it by, I don't know, 5. So let's practice the algorithm, that process that we learned years ago. I realize that it's gone the way of the dodo bird for a lot of us just because of how we use our calculators, and I get that, but watch out. So first thing we want to do is we want to set it up old school. So we want the 3, 4, 7, 6, 1 inside of the long division sign, and we want the 5 on the outside. When you do this here today and tomorrow and probably Wednesday, you won't be putting just numbers. You'll be putting polynomials on the inside and on the outside. So where does the process begin? What's the first question that we ask ourselves? Yeah, we ask ourselves, can 3 be divided by 5? Or I guess more to the point, can 5, the divisor, go into 3? No, so we bypass that and head to the next one. Can 5 go into 34? It can. How many times? So we're going to put 6 right here. I'm not going to skip any steps here, so don't speed race me, okay? The next step in the algorithm, as you know, is to multiply what you put up on top by the divisor. And what is 6 times 5? So we put 30 here, and then the next step in the algorithm now is to subtract. It's been a long time probably since you've had to do this. And when you subtract 34 minus 30, you get 4. And it's at this point that you bring down a new guy, and that is 7. And the algorithm at this point officially resets. We're back to the beginning. So now how many times does 5 go into 47? 9 times. So we stick a 9 up here into our quotient. And 9 now times 5 is, so we put the 45, we put a minus sign, and we subtract. 47 minus 45 is 2. And then we drop down the 6. 5 goes into 26 5 times. 5 times 5 is 25. Put your minus sign and subtract. 26 minus 25 is, drop the 1, and the algorithm for the 3rd time now has reset itself. 5 goes into 11 2 times, and 2 times 5 is 10, and then we subtract, and we are done-ish. Now, the way we're going to be expressing our answers today is going to look like this. It's going to be, well, if you let me finish my thought, then I'll explain to you. We're going to express our answers as quotient plus remainder over divisor. You're not writing that down. That's never a good idea. I try to do my notes as neatly as I can so that when you take notes, I remember as a kid, like in college, sometimes I never knew, what does my professor want me to write down? In this class, generally, I try to write as neat and colorful as I can so that if I write it, you write it, and then you've got notes that I want you to have. Yes, so it's quotient plus remainder over divisor, Q plus R over D. So we're going to label this now in our notes. This thing up here is the quotient. This thing down here is the R, the remainder, and this guy out here is the D, divisor. So this might feel a little odd to you, and it might look maybe a little different than you're used to, but I would write this answer as 6,952 plus 1 over 5. If this were fourth grade, we probably wouldn't put the plus sign. We would probably just put 6,952 and 1/5. That's the way somebody, I don't know what their name was, I don't know who your teachers were, but somebody taught it to you that way. And so if it helps you, obviously you have this written down, Q plus R over D, but if it helps you, it goes clockwise, which is pretty cool. So if you notice, we start up here, and that's what we write first, and then we go plus this over this. So it's like a clockwise pattern starting at the top. Got it? That question won't even have any relevance here in about 5 minutes. So what I wrote on the television is exactly what I want you to write in your notes. Okay? Decimals will not exist here in a moment, you'll see. So again, it is quotient plus remainder over divisor. Good so far? So we're not going to review that algorithm again. By the way, sometimes you don't get a remainder, I'll say this, and that renders this portion of your answer unnecessary. So like if I had gotten a remainder of 0, then my answer would just be Q. I would just write the quotient and call it good. All right, let's get to it. All right, watch out. Here we go. So we're going to take a polynomial. And your next quiz will just have this on it, right? I'm not going to add anything else in. This will be a few days of practice and then a quiz. So your next quiz will just be dividing polynomials. So we're going to take a cubic 4-term polynomial, and we're going to divide it by a linear binomial. Are you ready? It'll be really important for you to follow steps very, 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 very literally. And if at any point I lose you, just do what people do. Just ask. Just cut me off. It's okay. Stop me right where you get lost so I can nip it in the bud. So step 1 is we're going to set this up properly. We want to set it up as a proper long division problem. So we're going to want to set it up as 4x to the third plus 15x squared. Sorry to make you write this again. In the future, for my next few, I think I have 3 more examples, I will just write them already in the proper format for you. So we have that divided by x plus 3. So after today, we'll be able to say, now I can add, subtract, multiply, and divide polynomials. And I'm going to keep us in the comfort zone. These can get really nasty. There's another process for this called synthetic division. And if you're interested, after we're done, I'll teach you synthetic as well. It's pretty cool. But these will be user friendly, so to speak. You ready to begin? Okay, well, here it goes. Step 1 is, if you think back to the algorithm, we ask ourselves, how many times does the number on the outside go into the first part of the inside? So what we're going to do is we're going to follow that, and we're just going to ask ourselves this: how many times does x have to be multiplied to make 4x to the third? Don't even look at the 3. Don't look at all the other stuff. Only look at what I've underlined in yellow. What do you have to multiply the guy on the outside by to turn him into the guy on the inside? Okay, so I know I need to multiply him by 4. What else do I need to multiply him by? Yeah, Brandon, good. So the basics are going to help us here. We know now that if we multiply, I'm going to stop right here. I see a shaking of head, and I take that as a question. You and I both know, I'm going to change this one to yellow also, that if we multiply the 2 yellow things together, we get the thing inside that is yellow. And I will stop right here until we all agree with that. Yes. Don't look at this or this. I just need your agreement that what I put up atop on the quotient line, when I multiply it by what's out here, it equals what's in here. So are we all in agreement with that? Okay. The next step in the algorithm now, if you, what? Because this is x to the first. So if you were to multiply x to the first times 4x to the second, you would get 4x to the 1 plus 2, which is 3. Do you remember? We're dividing and multiplying here. So when you, right. Are all the light bulbs on? Okay, good. Then we can proceed. So now what you've done, now that you've only looked at the yellow things, I've changed colors on this because I really want you to see I'm not looking at the +3 and all the other stuff at the end. I'm only looking at what I need to look at. Now you're going to take this thing that's out here and you're going to multiply it by the divisor. And that's going to involve, of course, the distributive property. So, ready? What is 4x squared times x to the first? So we're going to write that right here. If you don't get the same thing as what's above it, then you have to ask yourself, well, what am I doing here? Because clearly that's the whole point. And then what is 4x squared, follow the second red arrow, times 3? Yes. So far, so good? It'll take you a while to buy into what I'm about to say, but we have done absolutely nothing different than what you learned in 4th grade. It's just buffed way up for algebra high school stuff. What is the next step in the algorithm? That's the only word I need is subtraction. The next step in the algorithm, if you go back and look at the example from before, the next thing we always do, once we figure out, okay, 6 times 5 is 30, you, without even thinking about it, you went off to the side, put a minus sign and drew a line, because that's just what someone got stuck in your head like 5 years ago. So let's do the same thing. I'm going to put a minus sign. However, I'm also going to put some parentheses. And the reason for that is because I'm not just subtracting 4x to the third. I have to subtract the entire thing. This is the part, you should not be lost yet, for the record. I'm not saying that you're dumb if you are. That's not, you should be okay now to hear. This is the part where you can't daydream. Don't be the kid that doesn't hear this. We're subtracting a polynomial, and as you know from your last quiz, which you all knocked out of the park, you know that when you subtract a polynomial, you have to distribute a negative through all of it. You've done this a lot of times, a lot. So right here, I have 4x to the third minus 4x to the third, and what does that make? It cancels. So don't put 0, just don't put anything. Now, right here, follow this blue arrow right here. What's the answer to that? Excellent work. It is 3x to the second. And that would be a good time for someone to say, wait a second, what are you smoking the crack? 15 plus 12 is 27. But remember, that minus that's on the outside is actually making that plus 12 into a minus 12, so that when we combine them, are you with me, Kale? What is the next step in the algorithm? Bring down the plus 17x. So the 17x with the plus sign comes down. And this is where you heard me say earlier, the algorithm now starts over. Now, what we're going to do at this point is we're going to figure out how many times, and I'll try to, here, I'll use green this time. What do you have to multiply this green x by to turn it into this green 3x squared? Yes. And again, my focus isn't on the whole problem now. Once I get back to the beginning of the algorithm, I'm only about first term of the divisor going into first term of stuff inside. So if I want green x to multiply to make green 3x squared, it has to be multiplied by 3x.
I need to know, like, Is there going to be a net?
Well, yeah, there's a very specific reason this is our first example, because there's not a minus sign to be found. Yeah, so this is all just a warm-up positives coming out the wazoo. Good so far? We're back at the beginning of the algorithm now, and so now we're taking the green 3x up on top, and we're going to distribute it through the red parentheses. What's the first answer? And what's 3x times 3? Just 9x, please. And now I draw in my line and remind myself that I am doing subtraction, so I shall, because I did 3x times 3. So once you figure out what goes on top, that new guy on the top multiplies by all the stuff in the divisor. That's the stuff off to the left. Got it? And now we subtract. Again, I'll use little blue lines. What is 3x squared minus 3x squared? 0. If that doesn't cancel, you have to ask yourself, what am I doing? I'm wasting time. The whole point is for that to cancel. It always has been. Now, what is the answer to this blue arrow? Very good, you guys. So that blue arrow right there is 17 minus 9, which is 8x. And then what do? Bring down the 24, and the algorithm is reset again. And the same question I will ask again. This time I'll switch colors, and I guess I'll go to red. This red X out here that I'm putting, you see where I'm drawing, I need to know, what do I have to multiply this red X by to make this red 8X? Correct. And now I'm to the end of the problem where I don't need to multiply by any more X's. I just need to multiply by 8. So up here, I'm going to put plus 8. And Kale, you asked a question about this a minute ago. So just so you're clear, what's about to happen now is this 8 on the outside is going to multiply by that, and it's going to multiply by that. What is 8 times x? So I'll put 8x down here. What is 8 times 3? And I'll put a 24 down here. And then the next step is for me to subtract, put it in parentheses, put your little dividing line to, finish off the subtraction. What's 8x minus 8x? 0. And what is 24 minus 24? So this, as will be a lot of the problems in today and tomorrow's work, has no remainder. So your answer to this problem is right there.
So you don't have to go back through and...
Oh, no, I see. No, your question caught me off guard, but now I get, you're talking about this guy. No, nope, never. You're only worried about the first term. It's like magic. Scale of 1 to 10. 1 is, I want to murder you right now. 10 is, that was actually super, super easy. Where are you? Okay. Nothing to it. All right, let's try example number 2 and see how you feel. What was that? That's 9. That's pretty good. Okay, example number 2. And again, I'll just write it the correct way this time for us. So we have 6x cubed minus 11x squared minus 26x. If you allow this week to be enjoyable, it will be. It's just good, fun math. It can even be relaxing if you let it be. Spoken as a true math dork. So there is our problem. Again, a cubic 4-term divided by a linear by. Step 1. And again, I'm going to go vandal mode on you here, and I'll fix this in a second. But in case I didn't do a good job of explaining this the first time, step 1 is only to ask yourself, what do you have to multiply 3x by to turn it into 6x cubed? 2x squared. We need a 2, and we need an x squared. And so we're going to go up into our quotient. That's up at the top of the division problem. And we're going to put a 2x squared. got to have tunnel vision to be good at this. You got to say, what am I? And that was why I scribbled out all that stuff in red. I'm just trying to accomplish one task. And now I'm going to take the 2x squared and I'm going to distribute it through the divisor. Because I need x to the third. I had x to the 1. I need 2 more. I need 2 more. Because if I'm trying to multiply to make x to the 3, and my divisor has x to the 1, not to ask a rhetorical question, but how many more do you need if you have 1 and you need 3? If you have 1 and you want to change it into 3, you need to add 2 more. So that's why we put a 2 on the x squared. So like if right here, Kale, were like a 5, I would have said I have 1, I need 5. On top, I'd have 2x to the 4. You with me? Okay. So now it's time to do the distribution. That's the multiplication part of the algorithm. Apparently it won't let me go back anymore. So here we go. We're going to take the 2x squared and we're going to multiply it through the red parentheses. What do we get? There you go. And the next step in the process is non-negotiable. Put your little, I call it a division line. It's a dividing line. It shuts off your subtraction problem from the rest of the world. And then you put a minus sign and you don't forget your parentheses like this. Sam, are you with us? You sure?
Yeah.
So what is 6? Go ahead, Colby. Because I took 2x squared and I multiplied it first there to get 6x to the 3. And then I multiplied it here to get 10. So you're always, anytime you place something new on the top floor, Colby, you're going to distribute it through the divisor. We good to press on? So here we go. When we have 6x cubed and we take away 6x cubed, of course, they cancel. That's the whole point. Now, these are the mistakes that usually after about 15 minutes of this, no one doesn't understand the process. Everyone understands the process. There will be 100 mistakes in this room over the next 3 days, and every one of them is going to be rinky-dink, garbage crap, 4th grade nonsense. You've been warned. So add well and subtract well. You don't want to get in your own way. So for my x squared column, I have negative 11x squared minus 10x squared. What is that? That is negative 21x squared. It's going to ruin your own week if you say something asinine there like negative 1x squared. Right? Don't get in your own way. And then I'm going to drop down my minus 26x and the algorithm starts over. So yet again, I'm going to switch pens here and I will fix this in a second. But for anyone who's a little bit concerned right now, all I want to know you see the two white things on the board? All I want to know is what do I have to multiply the 1 up on the outside by to make the 1 down below? I need to multiply it by a negative, and I need to multiply it by a 7 to make the 21, and I need another x. Thank you, Brandon. That was perfect. So I need to multiply by negative 7x to make white thing on the outside turn into white thing down below. So now I have to get rid of all my vandalism, and let's go.
So let's say there's
Not in this case, because if this out, I assume you're talking about this.
Yeah.
If that were a negative and we were trying to multiply it to make a negative, then no, we wouldn't need to multiply.
What is
The answer to this question, you and I could go back and forth like this like 30 times. The answer to the question every time is going to be, what do you have to multiply this by to turn it into this? And the answer will always just be, what do I need? If you got a 4 and you want to make a negative 8, use a negative 2. If you got a negative 2 and you want to make a negative 10, use a positive 5. That answer is always just going to be the same. What you need is what you multiply by. So I'm going to go back to what Brandon said, and it was perfect, that we need to multiply by a negative, and we need to multiply by a 7, and we need to multiply by an x. And now comes the distribution step. So let me get rid of these red arrows and let's begin. This time, what are we distributing through the divisor? Say that again. Negative 7x. Perfect. Negative, and that's really important. So you're taking now negative 7x and distributing it through to here and to here. No little mistakes. What's the first answer going to be? Perfect. Negative 21 x to the second. The next one's going to be minus 35x. And at this point now, we're going to put a dividing line to seal it off. We're going to put a minus sign, and we're going to put some parentheses. And now we have to do the math. When you do your x squareds, obviously they're going to cancel because, well, duh, it's the whole point. And again, there are no little mistakes. What is negative 26x plus 35x? Good. So right here, I'm going to bring down a positive 9x. I'm going to bring down the 15. And yet again, the algorithm is reset. I can go Vandal pen again. I can go like this, just in case anyone still wonders how or why I'm going to do what I'm about to do. My question still remains, of the white things you can see on the board, if I were a kid, that would help me focus. That would make sense to me. I can only see those. I'm not looking at anything else. What do you have to multiply 3x by to turn it into 9x? That's what we'll multiply by then. So we're going to multiply up in that top row by plus 3. Put a plus, of course, because it's positive, and I'll get rid of my red arrows, and we'll redistribute again. So what is 3 times 3x? I'll put that down here. And what is 3 times 5?
45.
I'm going to go with 15. You're fine. And now I'm going to subtract. And when I subtract, I'm going to get 9x minus 9x, which cancels, 15 minus 15, which cancels. Yet again, the remainder is 0. So what is my overall answer that I'll type in? Good. Good.
Scroll down just a little bit.
How's that? You're welcome. And by the way, this I'm recording right now. I think I am, and this I'll post on Canvas. So if there's any part of this that you want to go back and watch again, you're obviously welcome to. It'll just be a little, if you've never watched one, it's just a little embedded YouTube video. It'll be right there in your Canvas page.
How many subscribers do you have?
I don't know. Ready for the next one? I have 2 more examples, and they each serve a purpose. So I didn't want any extra like fluff, but 4 was the bare minimum. So our next one is 2x to the third minus 13x squared minus 8x plus 7. We're going to divide that by 2x minus 1. Chance, you got this written down? Sure looked like you were sleeping. I have to assume I was seeing things. As I've always said, I can only imagine how boring this is. I'm not just saying that to reverse psychology you. I imagine if I were 17 years old sitting through this lesson, I probably would have wished my mind and body were someplace else. So I feel your pain, and I just don't just say that to like be on your side and be that guy. I get it, but I don't care. It's not your job to sleep. It's your job to be a part of this. So using my pen, again, I will ask myself, and I'll stop doing this eventually. I just think if by chance you're still out there and don't know this step, what does 2x have to be multiplied by to make 2x to the third? First term, go into first term. That's all I care. Right, this time I don't need a number. All I need is an x squared. Good. So I'm going to multiply up here by just x squared. Nice and clean. Now we're going to take the x squared. Let's see if I can do it this time without arrows. Fingers crossed. I'm going to take the x squared and I'm going to distribute it through both parts of the divisor. I get 2x to the third. Yes. So I get 2x to the third minus x squared. Because x squared times 1 is, of course, just x squared. And now I draw my dividing line. I put a minus sign, and I put parentheses, and I don't mess up. What is 2x cubed minus 2x cubed? Gosh, imagine that. They cancel. Careful.
14x.
Nope. It's negative 12x squared. And I will draw a couple of yellow circles because this is where all of your mistakes will occur. Not like I'm a future teller clairvoyant. Just trust me on this one. So there's a minus 13x squared minus a negative x squared, which is really saying negative 13x squared plus 1x squared, which is why we get negative 12x squared. So knowing going into this where your mistakes will occur, that might help you to focus. When you get there, slow down, pay attention. Now I'm going to drop the minus 8x and the algorithm has reset. What do you have to multiply 2x by to make negative 12x squared? I need a negative, I need a 6, I need another x. Good job. Right. I'm trying to turn a positive 2x into a negative 12x squared. I need a negative, right? You put whatever you need, brother. Now, what are we distributing through the divisor? And don't say 6x. Negative 6x. Very good. And so as I distribute that, I need to be cognizant of that it's a negative. So as I distribute it through, all my signs are going to change. So the first thing is going to be negative 12x squared. What's my second one going to be? And we're almost there. Draw your dividing line. Bring in your minus sign. Bring in your parentheses. I'm going to show you a trick on the next one that you can take or leave, but I like it. It's usually what I do, but I don't start with it because it'll blow your mind. So what is negative 12x squared minus negative? That cancels. Negative 8x minus 6x is negative 14x. And then I drop down the plus 7, and the algorithm yet again is reset. And it's what? Yep, I need a negative 7 up here. Right, Kale? We need a negative because we're trying to turn a 2x into a negative 14x.
If we see like we can put negative 7 minus 1, we can kind of cancel out. Can we stop there if we see it?
I think you should finish because we're not always going to get. I started you with remainders of 0 because I'm a nice guy, but I think you should just follow through. I think. Anyways, when I take negative 7 and I distribute it through the divisor, I get negative 14x. And then I get what? Positive 7. And yet again, we have a match and we cancel. What's our answer? Okay, I know that you're just dying here, and I'm sorry. How ironic that I would say that and then give you another one, but there is one more example. So this will be it. And I'm going to show you a little trick that I use that I think you'll like. I think. So we have a quartic 5-term being divided by a quadratic trie. But the basic idea will not change. Got to have the tunnel vision. Ready? I wanted to point something. We are. These are still polynomials, bro. They're just bigger polynomials. I wanted to show you something, and I know you're probably half asleep, so perk up, stay awake, and listen, because I think this will help you. Are you aware of the fact that every time, you know how we have to put this minus sign and then these parentheses? You know how we keep doing that? You know what I'm talking about? Rather than put the minus sign in the parentheses, I'm just going to change the signs as I go, knowing that that's going to happen anyways. Like, let me circle this in yellow. What actually became of this negative 12x squared? It really was a plus 12 when we got down to it. And what became of this plus 6x? So from now on, when we multiply and we're distributing through the divisor, whatever we get, when we plug it back in, we're going to actually just do the dead opposite of it. And then we don't need the stupid parentheses and minus sign anymore. We can just combine like terms. You'll see. Super slick, and it actually helps a lot. So let's begin. This one I'm going to have to eventually scroll. I will run out of room on this. So let's begin. Again, my focus is only on the first term of the divisor going into the first term of the dividend. So what do we have to multiply? Nice job, Colby. That was a perfect answer. We need 2, and we need 2 more x's, so we're going to do 2x. Oops, I got to get rid of all my vandalism. Sorry, I got to go back. There we go. Perfect answer, Colby. So we need 2x squared. Now, the 2x squared, Chance, are you with us? So when I multiply the 2x squared, I'm going to have to distribute it 3 times this time because my divisor is a little bit longer. So Kale, this time when I distribute, it's going to go to there and to there and to there. It's okay, right? No big deal. Now, this is what I was talking about 5 minutes ago. When I multiply through, I want you to catch this. What is 2x squared times x squared? I'm going to put minus 2x to the 4th. Because again, I'm going to have to change all the dang signs anyways. Let's just do it now and we can dispense with all the confusing parentheses. Second distribution, what's 2x squared times 8x? 16x to the 3rd, not this guy. I'm writing minus 16x to the 3rd. Got it? Change them now and then you don't need parentheses. It's awesome. And what is 2x squared times negative 8? It would be negative 16. You guys are right. I'm going to put plus 16x squared. So the problem's a little bit longer. The algorithm does not change. I put in my dividing line and I proceed and I cancel these out. And here we go. And this time you don't have to think about changing. Oh, I forgot I got to change it. Nope, it's already changed, bro. Yeah.
Actually, very not.
They're the opposite of what they would have been, Kale. They're the negative of what they would have been. This times this is negative 16x squared. You got it? Okay, so now it's time to do our subtraction, which is actually already done for us. Just combine. What's 17 minus 16?
1x.
And combine your x's. Isn't that nice? You don't have to admit it, but that's pretty sweet. Change the signs as you go. You'll have a lot more success with this. So I drop down my minus 24x. The algorithm is now reset. And again, my only focus, this time instead of super vandal pen, I'll just do this. I need yellow to become yellow. What do we multiply by? Good job, you guys. Just plus x is all we need. So plus x. Distribute through. As you distribute, change the signs. What's the first thing I'm going to write? Second thing? Negative 8x squared. Because again, it would have been 8x squared. I switched it. And it would have been minus 8x, but I put what Sam said, plus 8x. And now I draw my dividing line, and I combine like terms. I don't have to call it subtraction anymore because I already did the subtracting switch. For the x squareds, I go cancel. For the x cubes, excuse me, how many x squareds do I get? 6 minus 8 is negative 2x squared. And for the x's, what's negative 24 plus 8? And then I drop down the final plus 16, and the algorithm is back to the beginning. So again, color coding for your convenience. How does yellow become yellow? You have to multiply by negative 2. Now watch out here, because you're going to be multiplying, distributing with a negative 2. And on top of that, you have to be thinking about switching the signs when you're done, because that's what we have to do. So for the first distribution, what is negative 2 times x squared? It would be negative 2x squared. We're going to change it to plus 2x squared. Red negative 2 on top, going out to the 8x on the outside. That negative 2 times that 8x would be minus 16x. Not us. We're going to put plus 16x because we got to change it. And then red negative 2 up here times negative 8 out here makes plus 16, which not us. We're going to write minus 16. And I don't know how I found room for this, but we're going to go cancel, cancel, cancel. So all of your examples had no remainders. And so we don't have to write these as Q plus R over D. If this is delta math, which it will be, I just type in the quotient, the thing on top. Yeah.
So for now, since you put the other thing, I mean, we have like, you want us to.
You want to finish it until there's nothing more over here to drop. If there's things you can keep dropping, then there's more math you can still do. That makes sense?
Okay.
Yeah, I handed them back. You might have been at home with allergies or something. I already handed you. Sorry.